This set of problems is going to begin with a very simple concept and then finish by just making that concept explode in a much larger way. So when rolling a 12-sided die, what's the probability of rolling a 5? Okay, this might seem completely useless, and we have been through this idea, but we're going to list what's called our sample space, and this will help us know what we have to choose from. There we go. So what is the probability of rolling a 5? Well, I have 1 5 out of 12 numbers, so it's going to be 1 out of 12. It's really that simple. A number divisible by 5. Well, I have 1, 2 numbers that are divisible by 5, and so therefore it is 2 out of 12 total options. You can call that 1 over 6 if you like. A 3, well, there is 1 3. Oh my goodness, this is easy. A number divisible by 3. 3, 6, 9, 12. There are 4 of them, which gives me a third. An even number, well, half of them are even. So I'm just going to go ahead and put a half. If you wanted to, you could say, well, there are 6 out of 12. You could do it that way. Okay, now I'm going to get to some that are a little bit more complicated, but still doable. Let me grab a pencil because I might need to underline some things. I want to get a 7. Or I want to get a number divisible by 6. So in this situation, you may want to start marking them and identifying them, which means it was practical that we made this list in the first place. A number divisible by 6, which would be 6 or 12, which that one actually wasn't too bad. That was 3 out of 12. I've underlined 1, 2, 3 numbers out of 12, which is 1/4. Okay, now we get to some crazy ones. Well, a crazy one. Let's erase that. And you can tell it's still there, but whatever. We want a number divisible by 4 or a number divisible by 5. So a number divisible by 4, which would be like 4, 8, 12, or a number divisible by 5. So like 5, 10, and that's it. So again, it was practical that we made this list so we would know exactly what we're dealing with. And we have underlined 1, 2, 3, 4, 5 numbers out of 12. That does not reduce. So now we take probability and it explodes along with adjacency matrices and all kinds of fantastic stuff. So in a small pond, we have this information that deals with tadpoles and frogs and dead frogs. And if you read this, if you just scan this, you'll really realize that we have, well, tadpoles, frogs, tadpoles, dead, frogs, dead. So there are basically 3 categories. You have tadpoles, you have frogs, and you have dead tadpoles and frogs, okay? And we're gonna list every possible path that these could take. I've never done it this way, but I'm gonna jump in with this. We have tadpoles that turn into frogs. We have tadpoles that turn into dead. And then we have tadpoles that over the course of a short amount of time will remain as tadpoles, okay? And then we're gonna continue with this. We have frogs that turn into tadpoles. Actually, we don't, so I'll go ahead and tell you this is going to be a 0. Frogs don't age backwards. But we're going to put that anyway, just so we'll have all the information we need. We have frogs that remain frogs, and we have frogs that become dead. Okay? And now we get to some things that are technically incorrect, but whatever. Dead becomes a tadpole. No, they don't. That one's going to be a 0. Dead becomes a frog. Nope, that's going to be a 0. And dead remains dead. Yep, that's it. Okay, we're also going to write the adjacency matrix, and we're going to call it A. So A equals, I'm getting way ahead of myself, by the way. We haven't even put numbers in. We haven't even read this information. Oh, well. We're going to have tadpoles, we're going to have frogs, and we're going to have dead. We're going to have tadpoles, we're going to have frogs, we're going to have dead. Okay. Can't do anything else until we actually read the problem. So let's actually, well, read the problem. Let's start with tadpoles. 35% of tadpoles have turned into frogs. So from a tadpole to a frog is 35%. I'm going to call it 0.35. I will write it in red. 45% of tadpoles have died. So 0.45 have died. And then 5% of frogs have died. So I'm going to... Frogs have died, so that's not 0.5, it's 0.05. There we go. And we actually have enough information to finish filling this out. Notice I changed colors on that. I'll explain why in a minute. But basically, let's go back to tadpoles. Tadpoles can either turn into frogs, tadpoles could be dead, or at the end of a month, a tadpole could not have developed appropriately and remain as a tadpole and still alive, okay? I don't know how long they take, so I kind of made this information up. This may not be biologically accurate, but we're going to go with it. So here's what's about to happen. 35% of tadpoles turn into frogs, and 45% of tadpoles die. So 80% of tadpoles do something, which means that 20% of tadpoles don't, and I really hope you can do that in your head, but this is where the 20 comes from, okay? So 20% of tadpoles remain as tadpoles, so 0.20 goes there. And I used red for tadpoles. So everything coming out of tadpoles was red. That's just a personal preference. It helps the numbers not look so jumbled up. And just for the sake of filling it in, so tadpoles turn into tadpoles. Yeah, they do. Tadpoles turn into frogs 35% of the time. Tadpoles turn into dead 45% of the time. Okay, let's keep reading. Frogs turn into dead. Okay, fine. Frogs turn into tadpoles. No, they don't. That's not biologically possible. That one's going to be a 0. And then it leaves us with this common sense thing of, well, if 5% of frogs die, then the rest of them, 95%, live. Okay, so frogs turn into tadpoles. No, they don't. Frogs turn into frogs. Yeah, they do, 95% of the time. And frogs turn into dead frogs is 0.05, is 5%. All right, let's go for some obvious stuff here. Dead tadpoles don't turn back into tadpoles. Dead frogs don't turn back into frogs. And dead remains dead, okay? So 100% of the time, if you have a dead frog, it's a dead frog. And you'll never be like, hey, look at that dead frog that I'm going to keep for a pet for years. No, he's dead. Okay, so let him go. 0, 0, and 100%, which becomes a 1. So 0, 0, and 1. There we go. We have found A. Now let's find A squared. So this is what this is going to mean. By the way, this is A to the first power. This is what happens at the end of 1 month. Now let's find out what happens at the end of 2 months. See? Okay, so at the end of 2 months, we'll know how many tadpoles have turned into frogs, or how many tadpoles have died, or how many frogs have died, or whatever. So, tadpoles, frogs, and dead. Tadpoles, frogs, and dead. All right. And I'm going to type it in. You can use desmos.com/matrix. I'm going to use my calculator. So matrix, edit. I need a 3 by 3. Whoa, not a 33 by 6. That's just crazy. 3 by 3. That's too much information. 0.2, 0.35, 0.45, 0, 95, and 0.05, 0, 0, 1. There we go. All right, I have entered this as matrix A. You can do the same thing on, well, you know the website, desmos.com/matrix. And I'm going to square it. So matrix A squared, and it gives me this. I'm going to round to 2 decimal places. It just makes percents a little bit cleaner. And I will use the same color scheme just because I feel like it. So 0.04, 0.04, and this is 0.4025. I'm just going to call it 0.40, and this is 0.56. The third one is 0.56 if we're going to round that appropriately. And then we're going to have 0, 90, and 10, actually, because the 7 rounds up the 9, which rounds that up to a 10. So 0, 0.90, and 0.10, and then 0, 0, 1. And this was supposed to be color coordinated, and it's not, and I'm sorry. No! So I'm going to waste your time erasing or whiteouting. Or whiting out, I guess, would be more appropriate. 0, 0, 1. There we go. What percent of tadpoles are frogs within 2 months? Oh, 2 months, which means I'm looking here, okay? If this would have said 3, I need A cubed. If this would have said 12, I need A to the 12th, okay? It's just one of those things. Actually, at the end of this video, I want to show you something kind of cool. What percent of tadpoles are frogs within 2 months? Well, tadpoles turn into frogs. Tadpoles turn into frogs. 40%. So my final answer on this one is 40%. By the way, if they would have given you a number of tadpoles at the beginning, you can multiply by 40% and get the actual answer. Number of frogs. What percent of frogs are dead within 2 months? Frogs that are dead is now 5%. And I want to show you something. You know, all the tadpoles and all the frogs, they're all going to die eventually, right? So let's do this. Check this out. This is cool. What's their lifespan? Well, I don't know, but let's raise this to a high number. Let's raise it to something like 20. There we go. By the way, that is scientific notation for ridiculously close to 0. And I get all the way to the end. This is tadpoles that are dead, and that is 83%. So within 20 months, 83% of all the tadpoles you had to start with are now dead. So the higher the exponent, the more things go towards the dead column, because eventually they were going to die. So if I was to take this and raise it to the 200 power, all right, here we go. This is getting interesting. This is the last column. Again, this E -5, it's scientific notation. If you were to write it out, you'd realize how close to 0 it is. So very small percent after 200 months of tadpoles are still frogs. They're super elderly, but nearly 100% are dead. Nearly 100% of frogs are dead. There you go. See? Some interesting lifespan represented with matrices.